Thanks, Shiva. Yeah, and if you guys hear some more echo, just let me know. I think it should be fine if I'm the person talking, but if somebody from the audience talks, there might be some echo because this is a closed room. And sorry for that in advance, but having said that, let's begin. The way we have structured this talk is that first half is a little introduction of what is PLG and why PLG, especially for modern SaaS applications. And a lot of these challenges are for enterprise SaaS. Enterprise SaaS is a little different from B2C companies. The questions are different, the needs of the customers are different. And actually, when you are building a product like this, you are not just building for your customers, but your customer's customer. And your customers can want to modify this platform in many different ways to give their customers the best experience. So having said that, I'll start this talk. First, a little intro of what DevRev is and what we do. And thanks everyone for joining on this call. So DevRev, one second. Yeah, DevRev, okay, so the topic of this talk is basically achieving micro-tenancy in product-led growth companies with freemium business model. And micro-tenancy is just an extension of multi-tenancy. The main difference would be that in a multi-tenant system, just a multi-tenant system, there would be probably tens of thousands or hundred of thousands of customers. But in a world where you are starting with freemium and you are expecting your go-to-market strategy to be PLG-led, you would also expect a lot of traffic to come from individual developers, one or two people in the company who just want to try out your product. And for them, the experience, the needs should match. But at the same time, if you have a multi-million-dollar deal from a bigger company, they might want to use your platform in a very different way, in a more customized way. They might want to do certain things that the freemium customers don't. So how to make sure your architecture enables this, and more importantly, your architecture does not become the bottleneck in your go-to-market strategy. So I'm Rabi. I'm a founding engineer at DevRev. I started my career at Nutanix, where I was a part of the Carbon team. In simpler words, it's basically an hosted Kubernetes platform that Nutanix offered on top of its own platform. After that, I was at Google for a couple of years, where I worked on the GPay team. So I was specifically in the GPay merchant team, where we were trying to build a product that helps merchants take UPI payments reliably. And this is my third stint at DevRev. I joined pretty early on, and when I joined, I was probably the third or fourth engineer globally. And right now we have scaled up to 70, 75 engineers, and across product functions, we have close to 150 people. So there are a lot of learnings around the way, not just the technical part, but also how to scale the team, how to make sure your basics are right, how to make sure the fundamentals, the platform is built in such a way that more and more developers can help build features and they don't get stuck in the intricacies of building the platform themselves. So about DevRev, DevRev is a Dev CRM, and I'll explain a little while what Dev CRM means. Basically, it's a way for developers to empathize more with your customers. And what that means is that in a traditional day of any developer, there are so many incoming things. There are your PRs, there are people commenting on your PRs. There is an actual system of record where you have all the tickets and issues that are assigned to you. There are your managers are basically asking you to update a ticket. Your product leads are asking you to update an issue. People are asking for ETA. So there is a lot of noise in this. But at the same time, a lot of important feedback is missing. For example, generally your PMs or your sales rep would come up with a requirement and they would get translated to a PRT, which just becomes a Jira ticket somewhere. We want to go one step further, and we want to make sure that when your customers are talking to you, to the point where you decide to narrow it down, create a PRD from it, or create a GitHub issue from it, or a Jira ticket from it, you understand the entire, you as a developer understand the entire life cycle, while at the same time, the customer rep also understands the status of what he's asking, whether it's prioritized, it's non-prioritized, whether you can help in getting it prioritized. So our aim is to reduce all this noise, bring in these 1,000 different data sources from GitHub, from your sales integration, from your other support CRMs, and provide a central way for you to look at that entire life cycle of a feature, the entire life cycle of a bug, the entire life cycle of a customer found effect, right? So how it works is basically a developer works on something called issues, which are very similar to what a GitHub issue looks like. Those things are called work in our system. A developer creates and updates and closes work, and the work is actually tied to something called a part. Part is the way your company structures and sells its product. Generally, a company would have a portfolio of probably a single product, but within the same product, there would be multiple capabilities. And within each capability, there can be multiple features. So if I take the example of Amazon AWS, for example, the product might be one AWS, but within that, there are multiple capabilities. There are S3, there is EKS, there is ECS, there are all these different capabilities. And within each capability, there are multiple features. For example, S3 can have multi-region replication, S3 can have some sort of integration with your cloud front. So this is the way your customer looks at your product. This is the way your customer understands your product. But at the same time, it may or may not map to what the developer thinks of as ecosystem. Like there are probably same services serving multiple capabilities, or there can be multiple microservices serving the same capability. So product is the central place where your tickets and issues and all your feedback collects. And from the customer's point of view, they work on tickets. They create tickets, they assign tickets to developers or tech leads. And while creating ticket, they consume parts. Since the parts are your user visible facade of your company, it is even easier for them to understand, okay, login feature as a feature is not working, or maybe some comments on discussions are not working. The product is like a focal point, and all work, be it issues or tickets or conversations, they all emanate from it. And this is how we create like a feedback loop where a conversation gets mapped to a ticket and a ticket gets mapped to a conversation. So our strategy since the beginning has been to go to market with PLG, and PLG has become more and more of a common word nowadays. It basically stands for product-led growth. Product-led growth is basically saying that forget all the old traditional ways of selling, which is a sales rep and a sales cycle, which takes longer to close. You bring customers to where you are. You delight them with an experience that they want to go and pitch it within their company. So product-led growth is basically growth inside out versus like outside in versus inside out, which is a traditional sales model where your sales rep and field reps are basically calling your potential customers, asking them for first meeting, second meeting, and so on. So in the past, at least in the recent past, there has been a lot of enterprise SaaS companies which have achieved this successfully. Slack, Datadog, and Calendly are just 3 examples, but I'm sure you can think of many more. And how they did this was they first made products discoverable by developers. So forget all the barriers of having a credit card to just use one of these. One developer or one team can go on board to these products, get a simple rate limited, feature limited version of it, understand how it works, understand what pain points it solves, and then you drive adoption with freemium users. You get more and more of these freemium users. The users can be one person in an organization versus it can also be one team in a multi-team organization. And the company generally derives value by upselling to premium users. Once you have them through the door, you tell them the other things you can do. You tell them how it integrates with the other suite of features that you have built. And then slowly and steadily, you bring these users to a premium category. And even within premium, there are tiers. Not all companies, not all customers are built equal. Some are small 5-member teams. Others are like 50% developer orgs. So for everyone, there is something. There is a pricing plan for everyone. There is a solution that makes their lives easier for everyone. So this is the PLG model. And ever since the inception of DevRev, we have been talking about PLG and how our go-to-market strategy is going to be PLG. And what that means at the technical level is your product architecture, your system of record should enable this and actually should be able to support these freemium tiers, so to say. And in a model like this, generally there are 95% freemium users and only around 5% premium customers. And the 5% premium customers, in a way, are subsidizing the infrastructure cost of the 95% premium tier. So your multi-tenancy should not be so expensive that each organizational creation leads to even higher and higher infrastructure costs. And the other facade of PLG model is community. Uh, you need a positive feedback loop from the community. The community should come to you, and community is the one which will drive adoption. And freemium is a great way to get community. And to have community, you need to give them back something. We like most commonly use our APIs and webhooks and stuff like that. But also there are forums, there are developer evangelism, there are these integrations that you build on top of your platform and you open source just to show the world what you can do with your APIs and webhooks. So these two things are sort of the founding pillars of all the decisions we take inside our company in terms of architecture, whether A versus B. Each A versus B kind of discussion finally boils down to, can it support product-led growth? Will it scale to 95% freemium users but only 5% premium customers? Can we make it open and extensible so that there are more APIs, there's more community, and then there's more adoption? And what it means is that there are these three things that I'll talk about, these next three slides. This is what it gets boiled down to in each architecture decision. One is multi-tenancy. Even if you just have 5,000 or 10,000 orgs in the first few years, you should be able to handle close to like hundreds and thousands of orgs. Because remember, these are not all customers. These are people trying out your product. These are people who are creating a organization or a workspace for themselves, trying out your features, figuring out how it makes their lives easier, if it makes their life easier, and maybe never coming back to it. So all data sources need to be tenant aware, and all of them need to scale to a point where it can support hundreds of thousands of organizations. The second thing I would say is customization. And this is very important for enterprise companies, irrespective of PLG or not. How it becomes interesting in a PLG world is basically customization is something. Let me first try to explain what customization is. It's basically your customers asking for certain fields that do not exist in your schema. Your customers asking for automation on top of these new fields that again does not exist in your schema. And when it comes to adding new fields in the schema, that is one of the most difficult challenges at the database layer. Because when they are saying, I want to add a schema, what they're also asking is, I want to be able to filter on that. I want to be able to sort on that. I want to be able to group on that. I want to write custom queries that look at this and then create a job out of it and publish some metrics to my data warehouse, for example. So when they ask for customization, they're asking for each and every part of your product to work with customization. And why it is important in PLG companies is generally the 95% tier is not very keen about the customization aspect. These are all smaller companies. They are using some other free product somewhere else. They are okay to live with not customization, but you cannot build for them. You finally have to build for the 100% use case. And the last 5.5% companies are very demanding in their needs of what they mean when they say they want customization. These are the main pillars, but there are a few more. Sandboxing is a very, again, enterprise SaaS concept, which is basically when a system admin, for example, a Jira admin, is customizing Jira, his or her changes are going to reflect to every developer. So if somebody adds a new field called PR link and makes it mandatory in all tickets that are getting closed, then this is going to affect all developers. So these are definitely not things that people do just at the click of a button. These are things that people want to create a sandbox from your live environment because they actually want to test how it works in your live environment. So they want to create a sandbox of a live environment, try these things out there, make sure things work as expected, their automations are not breaking, etc., and then bring it back to your original workspace. So sandboxing is not a new concept, but an important concept in enterprise SaaS companies. Then buy versus build is the age-old debate. And the way we look at it at DevRev is that building something from scratch is an expensive affair. It is not just about the infrastructure cost, it's also about the human cost. There is building something also requires people who understand it, people who can maintain this, and probably a team to QA this. So if you're building something, there should be a 10x value add from that. Otherwise, things that are already built, there are a lot of good open source and even closed source alternatives in some cases that solve 95%, even 99% of your use cases. Maybe start with that and only build things when you see that 10x upside. The last thing is scalable pricing. So we talk a lot about how systems need to scale, but actually even your pricing needs to be like in a scalable fashion. And what I mean by that is some features are inherently expensive to build, expensive in terms of compute, let's say. If you are providing something like a data warehouse, it is going to be expensive to build a data warehouse which is tenant aware, which has all the goodness that we talked about. So maybe you don't enable it for everyone. Maybe you keep it a premium only feature. And when you are designing an infrastructure, you need to make sure that data flow is not becoming your bottleneck. Your data flow can also be tenant aware. You can decide what part of the data flows into one versus other, depending on the pricing tier. So these are some of the core principles of designing a system of record, or designing a distributed system that can aid your company's PLG journey, right? So from now on, we'll dive into the architecture. And again, like I can go into 1 hour conversations about each of these slides, but I'll keep it a little abstract, and I'll try to explain the trade-offs we made in each of these parts, the trade-offs in terms of did we say this is consistent versus eventually consistency, what are we giving up at each point, and how it still needs to fit in all the core principles we talked about, which is multi-tenancy, customizable, scalable pricing, etc., etc. Right. So at a very high level, this is our architecture diagram, and this is a data flow diagram too. At the first layer are all these primary system of records. And when I say primary, it means that this is the data that is coming from outside your system. Either humans are actively creating tickets and filing tickets and creating issues, or there are some automations which are looking at your Datadog monitors, which are looking at your observability logs and creating issues. But the base knowledge does not exist in your system yet. It is coming from outside the system. So this is the first part, which is represented by parts, works, users, and social. And from there, everything is kind of a derived data, in the sense that you can compose these things into many ways, slice and dice this data, and derive these secondary data sources, which are going to add the factor of delight to your app. And they are generally things like search, your audit logs, your notifications, and everything that you expect in a modern enterprise, or even for that matter in a B2C world, right? We expect to have notifications when things change. You expect to be able to do a control K and search, command K and search, and that search needs to be aware of context. I mean, syntactic search was something that was popular 10 years ago, and most of the people looked at open search, Elasticsearch, and said that's good enough. But more and more with like Google's semantic search and the way Google has popularized the concept of not only understanding what you write, but understanding your intent behind those words and surfacing things that are more and more relevant to your search. So that is the semantic search, and I have a different slide where I go into a little detail of how we build that. And of course, like again, data warehouse and data lakes are becoming more and more common. You not only keep the current state of the data, but a historic view of the data. The data is then sliced and diced and understood in many different ways. And then there is a reverse ETL pipeline, which takes this high cardinality, high entropy data, boils it down into basic numbers and trends that people like and people want to look at. And they are fed back into the system through metrics. And these metrics are what we see as graph, trends, bar graphs, scatter plots, etc. And the last thing that I want to cover in this talk is the platform. Like I told you, everything has a business use case. Platform is the earth on which everything is built. Like If you get your platform wrong, there are lots of hidden costs that you will have, like in terms of constant refactoring, not understanding how to debug your system in production, making mistakes while doing authentication and authorization. So there is a platform that runs through this entire thing, and it works on the primary SORs, it works on the secondary SORs, it actually even works on data warehouse and reverse ETL, and it makes sure that everything you build, the application developers don't need to worry about how it is built, how it is deployed, how it is, how features are controlled, how authentication works, and all these basic principles. So that is probably the last part I will talk about before I open it up to questions. So the first part is basically this. This is the primary SOR and how it matters. It matters because again, we are talking about the same principles, multi-tenancy, customization, and we chose Mongo for our primary SOR, at least for the parts DB, the works DB, and the users DB. They are all built on top of Mongo. The reason we did that is a separate discussion, and why we didn't choose relational is probably something I can talk about after the talk. But even in Mongo, there are multiple ways of um, doing multi-tenancy. The simplest way is you can just have one database per customer, and you can have many of these databases. Separate way is doing one collection per customer, where there is one database, but there is one collection for works for tenant A and another one for tenant B. And the last is embedding multi-tenancy within document. It's same collection, same database, but the unit of tenancy is built into the documents, and your data layer makes sure that this constraint is never violated. All APIs need to be tenant aware. Again, this ties back to our platform where we have built a abstraction, like Golang library, if you want me to be specific, on top of Mongo. And apart from doing a bunch of other things, the main thing is that we have baked in this constraint that all operations need to be tenant aware, and the tenant needs to be passed into the context. And you can never fire a Mongo query that violates that constraint, even by mistake, right? So why we didn't do a collection and a database? The answer is very simple. It does not scale. And it does not scale because of the simple reason that each collection has at least one index, which is the index of primary DB, primary ID. And each index has a memory, in-memory cost, as well as an on-disk cost. And the index overhead for one collection is huge because it's like its own index memory structure, which is can be a V3 or something. But each collection needs to have one. So what you are basically saying to Mongo when you try to model it in one collection or one database per customer is that I want to have so many indexes created, so many indices created, one for each tenant. The index needs to be in memory for efficient lookup. You can't really do that on disk because the access pattern is generally very erratic. You can't basically say, okay, keep these things in memory versus don't keep these things in memory. And in general, unless you have your primary key index in memory, it is going to bloat up your performance by a lot. Also, like this is the minimum thing, but in practice, you would want to have more than one index. There are multiple fields, for example, priority, severity, owner, and everyone wants to do filter by priority, sort by priority, and stuff like that. So in practice, you end up with multiple indexes and not one. So that leaves us with one option, which is embedding multi-tenancy in document. And the way we have done it is by making the primary key, which is the underscore ID field in Mongo, a composition of tenancy unit plus a unique constraint. That unique constraint differs by collection, but the tenancy unit is embedded into that ID. And this abstraction that I talked about makes sure that you can never violate this tenancy unit constraint, and you can never look up. Each RPC comes with its own tenant ID, and you can never look up Mongo inside that RPC. You can never look up Mongo for a different tenant. The second part is customization. This is actually the reason we could not use a traditional SQL database. And customization is basically every customer is coming and telling you these are the other fields I want in your schema. For example, somebody comes and says, by default, we have each part has one owner. But a bigger org, it would not generally be one owner. It would be one developer owner, one PM owner, and one UX owner, one QA owner maybe. So these kind of customizations are what the bigger enterprises are looking for. Each customization means you have to put it into your primary SOR, and you have to be able to index them, because again, when they are saying they want a new field, they also want, so they are also asking for indexing, sorting, filtering, grouping on that new field. So again, like Mongo is a little flexible in that way, because in Mongo you can just store arbitrary JSON, but storing arbitrary JSON is not what we want either, because there is a schema and somebody has to validate that schema. So that's why we have an internal schema registry, which is a layer of abstraction away from Mongo, away from the primary SOR. This layer of abstraction basically talks about how to store your customer defined schema and how to make sure that all CRUD operations, specifically create and update operations, that you never can violate these schema constraints. For example, if you, going back to my example, if you added a new field called PM owner and you said it's mandatory, everyone who is creating a new part or updating a new part, updating the existing part, needs to make sure there is a PM owner for this. And again, like there are, it's not just about basic types of Excel string, int, bool, etc. They are also talking about composite type, because they want that owner field to be an user. The owner field cannot be just a string. And even though in Mongo you would ideally want to just store it as an ID, this layer of indirection needs to make sure that ID belongs to an actual user and it does not belong to something else, for example. So to build customization, we build the schema registry service, which is a layer of abstraction. The last thing is Mongo versus Dynamo. And if I come back to this slide, I said that parts, works, and users are on Mongo, but social is based on Dynamo. And the reason is the access pattern is very different there. The social part is basically, think of it like a Slack thread within a issue. It's high fidelity. There are lots of people commenting. You don't really want to filter or group by them, but you want it to be super fast. You want it to show you the last 10 messages as soon as possible, and you're always traversing it like a list. Like you scroll up, there is infinite scroll, and you're looking at just the 10 messages after that. So the access pattern is very different, and Dynamo is a very scalable way of doing this. Dynamo is good for small documents, and generally comments and all these social constructs are smaller documents. And it is very good for queries that involve just a primary key or optionally also a sort key. So whereas the primary key is basically the context in which you are, it can be a work, it can be a part. And the sort key is timestamp, because most of the time you're looking by timestamps. Like you're looking at the last 10 messages or the first 10 messages. Very rarely would you really want to look at random messages in no order. So a combination of primary key as the parent ID and sort key gives us great performance with Mongo, Dynamo. And that is what we have for the social aspect of it. Coming to the second part, this is the CDC Bus. And again, this is one of those topics where I can probably go on and on about. But this is our proxy for not having a relational database. Let me put it this way. That a relational database generally has a lot of goodness, which is transactions, which is you can define foreign keys and you can have cascading deletes and things like that. While it is true, you can do a lot of things on Mongo today using aggregate pipelines and transactions and stuff like that. You will eventually lose most of the benefit of using document DB like Mongo if you start modeling everything in a transactional way. So what we do is we have this internal message bus, which is called CDC. This basically stands for change data capture, with data from the primary SOR, and data means delta from the primary SOR, whether a new object gets added or removed or updated. This flows into a Kafka topic, and multiple listeners are listening from there. So one of them is listening to figure out, oh, do I need to generate notifications from this? Some other guy is listening and figuring out how to put them in Elasticsearch so that people can do semantic search on it, syntactic search on it. Some other consumer is listening and going and updating the primary SOR to implement something like a cascading delete. Like if your foreign key constraint is violated, then you delete that. So it is a central message bus and all updates to the primary SOR flow to this message bus, which is built on top of Kafka. And from them, it fans out to multiple consumers, and multiple consumers do to be more precise, and each of them do the right thing. Uh, how we implement this is actually pretty simple. There is something called Kafka Connect, which is a framework for running different like plugins, source plugins and sync plugins. Mongo is one of those sources, and there's a open source. It's a library. It's an open source project called Debezium, which has a bunch of these connectors. It has one for Mongo. All the changes from a Mongo change stream come through Debezium into Kafka Connect, and they sit in the first topic. Now, the reason we do not use this first topic is because if you do that, you are actually leaking database abstractions. Generally, and I think it's a very good practice, that only one microservice talks to the database. Databases are never like collections, more exactly, tables or collections are never shared between two microservices. So if you take this raw data that Mongo is giving you and you just ask consumers to consume it, you are basically leaking database abstraction. So what we do is we take this first stage, which is a Kafka topic, and then we convert it using our API, like our in-house written converters, to something which is more of an API. API in the sense that in 90% of the cases, it is the same kind of object that a GET call would return. And now this is an API contract between the service and all the downstream consumers. And of course, we have all the checks, no backward incompatible changes, no change of behavior without deprecating, having a deprecation notice and stuff like that. And from there, second stage, everyone listens to these changes and they act on it however they see fit. Just a note here, one of the challenges that we are facing with this approach, it works great for us to be honest, but one of the main challenges is schema management. Like these, we internally use protobuf, and protobuf is a compile thing, right? So sometimes people update the protobuf and they forget to come and update the CDC plugin, which is converting stage 1 to stage 2. So what happens is the old messages, the old serialization does not understand this new field, so it drops it. Right now we have a way, what we do is we just store the entire raw message that Mongo also gives us, so that in future we can audit it, and if we make a mistake, we can go back and replay it and stuff like that. But not a lot of use cases really need that. Some do, especially things like secondary databases like Elasticsearch and data warehouse. But in places where we don't, we just stick to the schema contract, which is the protobuf generated messages. Okay, so coming back to this, so we are done till the first half, and now the second half. It's basically, first I'll talk about the data warehouse. Data warehouse is again nothing new, but data warehouse is becoming more and more of a common pattern. Data warehouse is inherently expensive because you're not just keeping the latest data unlike all other places. You're keeping a historical view of that data, who created a comment, who changed the field, what was the priority before, what is the priority now. And all the intelligence and all the machine learning stuff can use this data, can use this and enrich our platform. Just to give you an example, we have something called auto suggest, where when you're creating an issue, we look up similar issues and suggest who the owner should be. It is not a simple string search. It is much more involved in that. It has a ton of different input it looks at. And this is one of those cases which is very, creating the model is relatively expensive compared to every other thing. And there are a lot of these use cases that are coming up. People want to see velocity burn down charts. People want to see a lot of trends that are emerging from that data. But at the same time, because it is inherently expensive, we want to make sure that we don't turn it on for everyone by default, or at least we have the option of not turning it on for everyone by default. So everything else that I talked about, it's actually built in AWS. We mostly use AWS and AWS services to build it. But in this case, just to suit the PLG model and make sure that we have this ability to turn off and turn on this feature, and even probably provide differential planning inside the paid tier. And just to give you an example, on a basic paid tier, we might want to run this kind of data analytics once in a day because these are expensive. But for a customer that really needs very up-to-date data, we might say, okay, we'll do this every hour and then we'll charge you differently. So we need to have the ability to be able to first isolate each tenant, and the logic remains the same, but the deployment parameters change from customer to customer. In this regard, we found Google's stack of Data Studio and Data Warehouse to be much better, because in Google Bigtable, you can have multiple data sets and we model each customer as a data set. What it also gives you is when you're running these analytics, big queries on top of your table, you can actually control the frequency of each of these run separately based on the data set. And again, this is the part we'll build probably very soon in the future. We're looking at your pricing plan, looking at your number of paid customers, seats, or whatever pricing plan we have. We will tweak it to make sure that this does not become a cost center for us. This also becomes like a place which people actually derive value from and they're willing to pay. The last thing is automations. So API, webhooks, and SDKs, these are great, but you also want the community to come to you and quickly play around with your API, webhook, and SDKs, right? And generally, these are like difficult to set up, because even if you write a great automation, you have to host it somewhere. You have to have a AWS account, or at least a code I know, or something where you can run this logic. So I think GitHub is a great example of this, where GitHub recently, I mean, in the relatively recent future, introduced GitHub Actions. What they actually help is, they always had APIs which were powerful enough. Like there were a ton of CI systems, Circle CI, Jenkins, and like they were all just as powerful as GitHub Actions is. But GitHub Actions just spearheaded the community. You can write a small snippet of code, you can publish it on their marketplace. People can just go to the marketplace, install the application writer. It can be one person sitting in his college dorm, does not need to care about all the infrastructure cost. The infrastructure cost can then be pushed to the customer, while the marketplace creator, the app creator, derives some value from installs. So to do this, you have to enable an automation platform. And again, one of those cases where Lambdas excel, because everything that I talked about, differential pricing, differential deployment, and like ability to do things for one tenant differently versus for other, these are very easy with Lambdas. Versus if you, let's say you built it on top of a traditional service-based architecture, then you'll have to build all these deployment parameters also as a part of your service-based architecture. So data warehouse and automations are some examples of where we thought that it is not enough to have just APIs and data and ways to download the data, but we need to spearhead this community building. And we took decisions that we thought will help us build a community even faster. So now the last part, the actually second last part is search. And search is all about bringing delight. In any SOR, eventually, for example, we have been using DevRev. DevRev has been in production for almost 6 months now, and we already have tens of thousands of tickets. And now, if you know somebody tagged you in a ticket somewhere, somebody tagged you in an issue somewhere, but you don't remember where. Nobody really remembers the IDs of the issues that people get tagged on. So you need to bring delight, and that search is one of the ways you bring delight. And search, like I explained initially, there are syntactic searches and there are semantic searches. Syntactic searches are relatively well understood today. You can create an elastic search or open search index. You can put documents that you are getting from Mongo via CDC into this elastic index. And you can use some simple models, even TF-IDF for that matter, where it helps you return. Like it's not as simple as string search, but then it is not as complicated as what Google is doing today with semantic search. And that is a good compromise to begin with. Syntactic search also runs into the same problem. How do you model multi-tenancy in Elasticsearch? And again, we took the similar approach, but the difference here is Mongoose has something called a wildcard pattern or wildcard index, where you can put all these custom fields not all, the indexable custom fields into one structure inside your MongoDB database and add a wildcard pattern. And that gives you enough of an index to actually sort and filter and group. Where it falls apart is it's basically a key value mapping. It's basically string to string mapping. It has no idea of like the kind of data underneath it. So it will not be able to do, for example, sort or range queries or stuff like that. And that is a compromise we are willing to live with, at least in the short term. But in Elastic, each field gets indexed, or at least the fields that you want. So here we took a slightly different approach. And what we did was we mapped all the custom fields to one of these prefixed fields. For example, let's say we allow each customer to create 10 new fields in any object. Now, theoretically, there are just 4 or 5 types of basic types, like strings, ints, floats, and booleans. So what we do internally is we create 10 string fields, 10 int fields, 10 boolean fields, etc. And we remap one of your fields into one of these. And again, that is a layer of indirection that is tenancy aware. That is what we had to build. And then while querying, you query for PM owner colon Rabi, but we internally convert it to custom field underscore string underscore 001 with value as my user ID. So this remapping and inverse mapping, because again, Elasticsearch will give you back this inverse mapping. You have to map it back to a schema that the customer understands. So this is again the layer of indirection we built on top of Elastic. And it works fine, but it has some issues, specifically like, let's take the example of TF-IDF, where basically you're calculating term frequency and inverse document frequency. That gets a little polluted because everything is sitting within the same index. So let's say one organization has 100,000 tickets versus some other has 10. This tickets is kind of polluting the score for the other DevRev, because if you have a very common word, for example, this is not working or this is a bug, those kind of English terms will show up in almost all organizations. Or login not working, let's say. Logging is kind of a feature that every company has. So one company having a lot of documents mentioning login will start polluting the score of the other organization, which probably does not have so many tickets. This does not have so many bugs talking about logging. So the next thing in this journey is the semantic search. And semantic search is more than, semantic search is a journey in itself, because you are trying to understand users' intent. And there are multiple ways of approaching this. We have something which we are calling context unification, which is basically your context, your journey on the app, which page you were at, what were you doing, what were you trying to do, and when did you bring up the search. All this is captured in context unification. And this is actually a custom database that we had to build, because there are a few things out there which are vector databases, which are, hosted vector databases, but none of them are tenant aware. Each of them are built by like each tenant is a database, and if you want to maintain this sanity, then each database has multiple documents, and this is not something that scales, not financially, and I don't think even system-wise it scales. So what we ended up doing was build our own vector database on top of RDS, basically Postgres, and vectors are namespace per tenant. Each tenant has a specific vector, and those vectors do not collide. Those vectors for tenant do not pollute each other. So this is a journey, and probably at some point of future we would want to do a talk on this, because there are a lot of unique challenges of building a vector database. A scalable multi-tenant vector database is not really a problem anybody has solved yet. Different people are working on it, and you can find a lot of different options out there, but all of them fall short if you bring it back to the PLG world, where you have 5% premium customers but 95% free customers, and the economies of scale don't add up in a lot of these cases. So I talked about most of these things, and the last thing I will talk about, and I'm almost out of time, so I'll try to wrap this up fast, is the platform. The platform, like I said, is the crux of building everything. Everything we do is built on top of gRPCs. Each microservice is talking to other microservices in gRPC. All request responses are captured in protobuf. And the platform is more than Inter-process communication, actually, platform is also about telemetry. It's about authentication, authorization. It's about having feature flags in any modern company, even B2C companies, B2B companies, whatever. Feature flag is a pattern that is emerging more and more. If you want to do continuous deployment, if you want to do continuous integration, you cannot wait till a point where the feature is completely developed. You have to keep on checking code at smaller intervals, and you need to make sure the effect of these small code changes do not end up compromising the overall experience of your app. So feature flags are a very well understood pattern. We use feature flags heavily, like I guess any other company right now. Our deployment story is built on top of um, mostly things that you find in the open source world. We use Kubernetes. We use Circle CI to actually build our containers and do the build and test thing. Those things then get pushed to ECR, which is then picked up by Argo. And right now we are working on integrating Canary deployments with Argo. Canary as a thing in itself is probably easy, but when you want to tie Canary to your application metrics, it that is what gives the value of doing Canary deployments, and doing that across multiple regions, multiple Kubernetes clusters is something that we had to brainstorm a lot. And again, for a future talk probably. But one thing I want to talk about here in detail and is gRPC. We are mostly I think 99.9% a gRPC shop. Even our gateway is written in gRPC, and we use gRPC gateway, which is an open source library by Google, which converts this gRPC things into JSON. So basically, when you see our public documentation, you will find references to JSON and not gRPC. But the JSON that UI and mobile and everyone sends get converted to protocol messages, which then travel inside our network, our VPC. And when they come back out, they come back as gRPC protocol messages, which are then serialized to JSON and sent back to the thing. The reason we choose gRPC, and we have invested a lot in DevRev specific gRPC layer, is because gRPC has a lot of good abstractions. First, it is language agnostic. So today we write most of the things in Golang, but tomorrow we might want to introduce some other language, maybe Java, maybe Rust at some point. So gRPC provides language agnostic way of defining schemas, defining inter-process communications. gRPC also has these amazing abstractions of annotations and interceptors, and we use them heavily for not just there are multiple use cases. Every request response is logged as in it is logged in a smart way where if the request contains an error, the entire chain of messages is logged. If it does not contain an error, then it is sampled. When you log a message, you have to be actually privacy sensitive, you have to be PII sensitive, and you have to you can't log in fields which are sensitive, for example, passwords or credit card numbers. What we did was we added an annotation called this field is PII, and while serializing it before writing it out to standard log, we scrubbed all the messages that are PII. So that is one of the ways we are using annotations. We also use annotations for validations. All our internal gRPC interfaces are very well annotated with what is the request type, what is the response type, even if it is string, how many characters are allowed, and a bunch of validations like that. And because we use Go, what we do is we generate the validation logic out of these annotations. So the Go code, which basically the one part is writing an annotation, which is just metadata, which says this is a string field of email type. But the other part is actually generating the Go code, which looks at the string field and has a regex which can map for email. So these are one more use case we use annotations for. Interceptors are very interesting. Interceptors are thing which run before and after your RPC. So we wanted to maintain this sanity that your business logic should not get corrupted with platform. For example, everyone needs authentication. Everybody needs authorization. Everybody needs to do some form of APM, like all our services should pass around trace headers, context headers, and stuff like that. So we have a bunch of annotations which take these proto request response objects, modify it or not modify it, pass it on to something else, and make sure that the business logic never gets corrupted with actual system logic, which is authentication, authorization, logging, tracing, and stuff like that. So actually that brings me to the end of my talk, and I'm happy to take any questions. Uh, any questions so far?
There's a couple in the chat.
I see. Okay. When building multi-cloud applications like this, how big a factor with respect to cost and data ingress? Exactly. So this is actually a very big concern, and that is why our entire ecosystem is inside a VPC. For Mongo, for example, we use Atlas because document DB, we didn't feel it's just as good as Atlas is, honestly. But that at least is VPC peered, so it is a little lesser in cost. The biggest cost we have while going out of data center and coming inside your VPC is Google Cloud and the big table thing. But there right now, our thesis is that the pros of having differential pricing outweighs the cost of doing network calls. It still stands like it still needs to be tested in the real world. But right now, we are first option is to keep everything inside the VPC, and only when you see a very like 10x upside of going outside your VPC, do you actually want to do that? Siddharth, does that answer your question? Okay, I'll assume that's a yes. So Abhishek is asking, what is your engineering team size? I believe choosing the right technology for every use case is every engineering team, but it could add friction in terms of adapting and maintaining the infra. Exactly. Engineering team wise, we are probably close to 75. It's actually distributed in 3 continents and like 5 locations. We have our office in Bangalore, Chennai, Slovenia, Bay Area, and Texas, Austin. So you are absolutely right. Trying to choose a right technology for every use case, especially in a startup like ours, is I mean everyone's dream, and everyone is going to get it wrong. And that sometimes there is friction in terms of I think this is a better technology versus that. But what we do is we have this philosophy more than engineering philosophy is just a company principle of disagree with commit. When you go into meetings like this where you are discussing technology, every engineer is passionate about the things he or she likes and has worked on. At the same time, when you are coming out of a meeting, you decide what you are committing to, what you're disagreeing on, but committing to, and you come and do it in a generic way. For example, all the gRPC stuff that I was talking about, we did not really start out first building that and then building all the applications. But more and more use cases came up, and more people brainstormed, and more people have developed this. We don't really have a dedicated team yet just to do platform engineering, but at the same time, like everybody has this notion of disagree and commit, where uh, everyone is actively trying to make the platform better.
Sorry, Rabi, I need to drop off. But if others have questions, please, and if Rabi has time, please feel free to continue. Thank you.
Okay, I can hang around for a little bit more if you have questions.